Understanding the significance of ancient technologies involves recognizing the innovations and techniques developed by our ancestors that have shaped modern civilization. These technologies range from basic tools to complex architectural feats and advanced engineering solutions. They highlight the ingenuity and adaptability of ancient societies, offering insights into how they overcame environmental and societal challenges. The significance of this point lies in the fact that examining these technologies can reveal not only the achievements of past cultures but also provide inspiration and potential solutions for contemporary technological and environmental issues. Additionally, studying ancient technologies can lead to a greater appreciation of human creativity and resilience throughout history. For instance, consider the Roman aqueducts, which were engineering marvels designed to transport water over long distances using gravity. This technology was crucial for the expansion of Roman cities and significantly impacted public health and urban planning. Even today, the principles of their construction inform modern water management and distribution systems. Another example is the antikythera-mechanism, an ancient Greek device used to predict astronomical positions. This complex gear-driven mechanism demonstrated advanced understanding of astronomical cycles, reflecting a sophisticated level of technological prowess that influenced modern computing and mechanical engineering concepts. The significance of ancient technologies can be further highlighted by exploring the opinions of contemporary scholars who argue that reviving or replicating these technologies could benefit sustainable development today. For instance, many advocate for the reconsideration of earth-based construction techniques used by ancient civilizations to address current environmental challenges such as climate change and resource depletion. However, there are challenges and controversies associated with this concept. One issue is the difficulty of accurately reconstructing these technologies without complete historical records. While some ancient techniques may seem innovative, replicating them today can be problematic due to a lack of understanding of all the variables and conditions that existed at the time. Additionally, there's an ongoing debate about the relevance of these technologies in a world driven by cutting-edge science and digital advancements. Some critics argue that focusing on ancient technologies may detract from the investment in futuristic innovations that prioritize solving contemporary global challenges. The exploration of ancient technologies connects with other aspects of this main topic by prompting questions about the evolution of human innovation and how historical knowledge can inform modern technological development. By examining these forgotten technologies, we gain insights into the cyclical nature of technological advancement and the potential for integrating past wisdom with future innovation, guiding us toward more sustainable and resilient forms of progress. Unearthing the mysteries of forgotten ancient technologies involves delving into the lost innovations and engineering marvels that ancient civilizations once employed, which have since faded into obscurity. These technologies, often passed down orally or inscribed in rudimentary forms, reveal a deep understanding of science, mathematics, and aesthetics that ancient societies possessed. Within the context of examining whether we can replicate these technologies today, this exploration highlights both the ingenuity of our ancestors and the potential benefits and limitations of contemporary attempts to recreate or derive inspiration from these methods. The significance of studying forgotten ancient technologies lies in their ability to expand our understanding of historical progress and cultural evolution. By exploring these lost techniques, we gain insight into the daily lives, priorities, and intellectual capabilities of past societies. Furthermore, resurrecting or adapting these methods might offer solutions to modern challenges, particularly in areas like sustainable architecture, agriculture, and urban planning. Consider the ancient Roman concrete, which has puzzled scientists for decades due to its durability and resilience. Unlike modern concrete, Roman concrete, made with volcanic ash, lime, and seawater, exhibits remarkable longevity and resistance to erosion. evidenced by structures like the Pantheon and aqueducts that still stand today. Another intriguing example is the antikythera-mechanism, an ancient Greek analog computer used to predict astronomical positions. Its complexity suggests a sophisticated level of engineering and knowledge of celestial navigation that challenges our assumptions about ancient technological capabilities. Advocates for exploring ancient technologies often emphasize their potential environmental benefits, as many of these techniques employed naturally available materials and sustainable practices. Moreover, enthusiasts argue that relearning these crafts could preserve cultural heritage and foster innovation by merging ancient wisdom with contemporary science. However, challenges persist in the replication of these technologies. The primary difficulty lies in the incomplete or inconsistent historical records, complicating efforts to fully understand the methods used. Additionally, there are controversies over the romanticization of ancient skills and whether they can truly address modern needs as effectively as contemporary technologies. The exploration of forgotten ancient technologies ties into broader discussions about innovation and sustainability today. As we confront issues like climate change and resource scarcity, revisiting ancient methods may provide valuable lessons or alternatives. Overall, the mysteries of ancient technologies not only enrich our historical knowledge, but also inspire us to think creatively about melding past innovations with present-day challenges. The concept of the role of lost knowledge in ancient innovations refers to the understanding that ancient civilizations possessed a wealth of technological and scientific knowledge, much of which has been lost over time due to various historical and societal factors. This lost knowledge includes techniques, materials, and processes that ancient peoples used to create remarkable innovations and structures, some of which modern science and engineering still struggle to fully understand or replicate. This point is significant to the broader topic of forgotten technologies because it highlights how the absence of certain historical insights can hinder our ability to reconstruct ancient methods, framing a deeper exploration of whether modern science can bridge these gaps. Several examples illustrate the marvels of lost ancient knowledge. One notable case is the construction techniques used to build the Great Pyramids of Egypt. Despite numerous theories, experts still debate exactly how such massive structures were erected with the limited resources of the time. Another example is Damascus steel production, a technique for forging blades first developed in the Near East and famous for its strength and distinctive wavy surface patterns. Though attempts have been made to recreate this steel, the secret of its original production process was lost around the 18th century. Supporters of the idea that lost knowledge plays a crucial role in ancient innovations often argue that understanding and recovering this knowledge can lead to advancements in modern technology, cultural appreciation, and historic insights. However, significant challenges arise, such as the paucity of archaeological evidence, the degradation of materials over time, and the interpretative nature of ancient texts, which may lead to misinterpretations or conflicting theories. Controversies and alternative viewpoints surface around these challenges. Some skeptics argue that even if the knowledge were recovered, it might hold limited contemporary value given the advancements in technology and science. Others question the feasibility of completely understanding these lost methods due to the cultural and contextual differences that have evolved over centuries. This concept connects to other aspects of the main topic by influencing the methods researchers and scholars use to approach the study of ancient technologies, employing modern science and interdisciplinary methods to uncover or replicate ancient techniques. Moreover, this interplay between curiosity about the past and the quest for modern solutions underscores a broader philosophical discussion about the essence and ownership of knowledge across time. Ultimately, exploring the role of lost knowledge helps frame the overall discussion about the potential for modern society to replicate the incredible feats of ancient civilizations, adding a layer of depth and complexity to the topic. Analyzing the feasibility of replicating ancient technologies today involves examining our ability to understand, reconstruct, and implement the advanced techniques used by ancient civilizations using contemporary methods and materials. This exploration is significant as it shines a light on the ingenuity and sophistication of past technologies, which often surpass what we initially assumed to be possible with the resources and tools available at the time. Understanding whether we can replicate these technologies allows us to gain insights into ancient cultures, enhance our current engineering practices, and potentially inspire modern innovations. Two specific examples highlight the feasibility of this endeavor. First, consider the Roman concrete, a material that has resisted the ravages of time and elements far better than some modern counterparts. Recent studies have shown that incorporating volcanic ash and seawater into their mixtures gave Roman concrete its unique durability. Efforts to replicate this could improve modern construction by producing more sustainable and resilient materials. Another example is the antikythera-mechanism, an ancient Greek analog computer used to predict astronomical positions. The precision and complexity of this device have baffled scientists, but understanding its workings is providing insights into mechanical engineering and has inspired new technologies in clockmaking and computing. Opinions supporting the replication of ancient technologies often highlight how these efforts enrich our understanding of history and technology, stimulate innovation, and foster a sense of continuity in human achievement. These insights bolster the argument that there is much to learn from revisiting historical technologies, potentially offering solutions to modern challenges like climate change and sustainable engineering practices. However, there are challenges and controversies surrounding this concept. Some argue that fully replicating ancient techniques is nearly impossible due to the loss of unique materials, specific environmental conditions, and cultural contexts that might have influenced these technologies. Additionally, ethical concerns arise about whether the resources dedicated to these projects could be better spent on contemporary issues. Analyzing the feasibility of replicating ancient technologies connects deeply with the main topic, as it not only underscores the impressive capabilities of ancient societies, but also encourages a re-evaluation of what past innovations can offer today's world. This pursuit informs other aspects of the discussion by highlighting the importance of historical context, interdisciplinary collaboration, and creative problem solving in our ongoing quest for knowledge and improvement of modern technologies.